All right, here comes the next part. Now, the next part, we have centripetal force, angular velocity, angular acceleration, and linear acceleration. Now, let's define centripetal force. What is centripetal force? Centripetal force is the force that keeps an object moving around a circle. The force that keeps an object moving round a circle. That is what we call centripetal force. Now, if you are running round a circle, if you are running in a circular path, what keeps you in that circular path is called centripetal force. What is providing this centripetal force? That is what is keeping you moving in that circular path. It is your what? The friction between your leg, your feet, okay, and the ground. The friction between your feet and the ground. It is what is keeping you on this circular path. That is what is providing the what? The centripetal force. Okay, centripetal meaning as in directed towards the center. Do you understand? So now the formula for centripetal force is, remember, force according to Newton's second law is equals to what? Mass times acceleration. Okay, so the acceleration in a circle is equals to v squared over r. Later, I will show you how this formula comes to, like, how it is v squared over r, the acceleration in a circle. Now, if you substitute for this thing here, so we now have that F is equals to mv squared over r. This is the formula for centripetal force. You can have it like this, since v is equals to radius times omega, we have F is equals to m bracket radius omega all squared all over r. So F is equals to m r squared omega squared over r. So cancel, we have F is equals to m r omega squared. 1 r cancels 1 r here. So this is another formula for the centripetal force. So either you have it like this or like this. Either you have it like this or like this. This is a formula for centripetal force. Okay? So this is it. Now we come to angular velocity. We come to angular velocity. Now, angular velocity is the rate of change of angular distance with time. What is angular distance? Theta is the angular distance. Okay? Yes. So angular velocity, omega, is equals to what? Theta over t. Rate of change. Remember, angular velocity is what? Delta theta over delta t. Okay? That is rate of change of angular distance with respect to what? Time. Or you can say with respect to change in time. Okay? So this is it. So, in calculus, like if the change is instantaneous, you can have that omega is equals to the theta over what? The t. This is what? Instantaneous rate of what? Change. Okay? So now, this is it. Now, the unit of this angular velocity is in radians per second. So omega is in radians per second. So that is it, the unit of angular velocity. So I'm coming back for angular acceleration and linear acceleration. See you in my next video.